Gerdau as a whole is a Brazilian-owned steel company operating in all of North and South America, pretty much every country. We produce long steel, which is for structural type components, and then we also produce special bar quality steel, which is what's produced here in Monroe, and that is primarily used for automotive applications. Our finished product going out the door is a round bar stock of steel, anywhere from 5/8 inch round up to 3 1/4 inch round, and then varying lengths depending on what the customer wants. Our steel bars are sent to forge shops, machine shops, all sorts of different facilities that then will cut the parts, machine the parts, stamp the parts out of the steel we produce, and then from there those parts maybe go to another supplier for automotive to be finished, and then they eventually end up at automotive companies like GM, FCA, Ford. All the big three use our steel, and it goes to the assembly lines to be put into vehicles from there. Here, how we produce steel is we actually are a recycler, so we use all scrap material to make new steel out of it. The nice part of our location, being we're in Monroe, just south of Detroit, is we get a lot of scrap metal from all the automotive producers in the area. We are one of the largest industries for recycling in the world. It's the second largest is the steel industry after the paper industry for material recycled. We bring shredded cars in, we melt them down, make new steel. We use old structural components, like you'll see old bridges torn down, those beams and stuff that were in there that are made out of steel. We recycle that kind of material. We charge that scrap metal into an electric arc furnace where we use 3 large graphite electrodes, similar composition as a pencil lead, only massive in size, 24-inch diameter, round carbon electrodes are used, 3 of them, and we use a massive amount of electrical energy arcing between them. Essentially, we're making lightning between these electrodes, and the tips of those electrodes can get up well over 10,000 degrees. So while you're arcing to the steel, scrap metal in there, you're melting it down. After we finish melting down the steel, we will dump that steel into a brick-lined or refractory-lined ladle, and that's how we can move the steel around. The refractory lining, which is like a brick, has a lot higher melting point than steel. So that's how, when you take a vessel lined with that, you can actually move steel from one location to the other inside this vessel without melting through the vessel itself. So from there, we'll take it to another station where we add basic alloying elements, manganese, chrome, moly, nickel, depending on what the customer wants. And we'll take that, add all those elements, and add temperature to get it to the proper temperature for further processing. There's certain elements in air that are exposed to steel that are not good for the quality of steel. So we'll put that big ladle of steel in a large chamber and pull vacuums to remove all the atmosphere in that chamber. And with that, we'll stir that with argon to stir the steel up and expose it to that vacuum. And that's what's going to pull those parts of air that are stuck inside the steel that are not good for quality out. From there, we take our steel up to the continuous casting machine. That's where we take liquid metal and re-solidify it into the next form of our product. So we will put that steel into a large, essentially looks like a bathtub with 4 holes. We cast 4 different strands of steel at one time. So coming out of that bathtub are small holes that go into copper line molds, which give you your best heat transfer, so you can solidify the shell and pull temperature away from the steel. Think of it as a Play-Doh fun factory. You used to press down the Play-Doh fun factory, you see Play-Doh coming out. It's a continuous strand of steel coming out. We spray a lot of water on it to remove heat so that we can cool it down, and we make 9-inch by 9-inch square, roughly yay big, and continuously coming out of this machine. 4 sets of those are coming out of the machine at one time. And then when they get to the bottom, they're straightened out and cut to a length that will be further used in our rolling mill. We will run that through a series of rolls that press, pull, draw that material out, and then essentially cut it to the customer's finished length that they want. The steel industry as a whole is a very safe industry, although when you see pictures and videos of it, it may appear as it would not be, working with steel that gets up to 3,000 degrees Fahrenheit. But all companies, including Gerdau, focus on every way of keeping their employees safe. And this has advanced over years as people have learned different things and technology has advanced. We use robots to keep people away from the steel as much as possible or keep them further away. When people can't be away from, let's say, molten metal or hot bars, we give them the proper PPE or personal protective equipment to deal with that. We have full aluminized silver coats that reflect heat away to help keep you cool. We do a lot of safety training. You go through 3 to 4 days of safety training when you start before you even get to go on the floor and be a part of anything. If there's anything concerning operators, they feel like it's unsafe, we stop operations until we figure out what we can do to make sure that that person feels safe in every aspect of their job. I chose material science and engineering when I was at Michigan Tech based on I came in really liking chemistry from high school. So I focused on chemical engineering, then realized chemical engineering has to do more with more processing than it is the actual chemistry aspect. So I found out about material science, which focuses on basically all materials at a microscopic level. What you can do, what you can add to materials to make them stronger, make them softer, make them more ductile, more brittle. It's a fascinating field to me of just the little things you can change on a microscopic level with materials and totally change how they react in their environment. If this is something you want to do as a career, you just have to kind of decide what path you'd want to go. We use electricians, we use hydraulic techs, we use millwrights, so you can go to a trade school, get that kind of schooling, and then come in and work here. We hire operators as long as they have a high school education. They come in here, and that's who makes our steels, our operators. And then you can come in like me. I came in as an engineer. I got a 4-year degree in material science and engineering from Michigan Tech, and I came in here at that point. So it depends on really what your aspirations are for what you may want to do as to what level of education you may want to seek after school, or even finishing up in high school. You may be able to get involved in trade schools and come work for us when you're done with high school. When I was graduating college, I found this opportunity, and what's kept me here since then is the people and just the fact that working around molten metal is one of the coolest things you can possibly do.